Now, if that is given in parametric form, we consider this example. Say we have a circle of radius 1. So, that circle is centered at 0 1. So, we have a circle at 0 1, it is of radius 1, okay. That is revolved about the x axis. So, does it touch x axis? It is 0 1 center, radius 1, yes. So, it will be revolved around what is the surface area of revolution. So, if you look at the picture, it looks this way. You have the circle which is touching x axis, of course, then it is revolved around this. So, you would get a picture like this, it is a surface. We want to find the area of this surface. So, since it is a circle, it will be easier to parameterize with say x equal to cos t and center is at 0 1. So, it is a plus r cos t, which is a plus cos t is cos t, and b plus r sin t, which is 1 plus sin t, right. So, x equal to cos t, y equal to 1 plus sin t, and t is that angle. So, it is varying from 0 to 2 pi. That is how we get the circle, parameterization of the circle. So, we have x equal to cos t, y equal to 1 plus sin t, t varies from 0 to 2 pi. Then we should obtain ds, which will be computed as square root of dx by dt square plus square dy by dt square and dt. So, to obtain that, we say x prime square, prime means here with respect to t, derivative with respect to t. So, cosine t, its derivative is minus sin t square. So, it is sin square t, and this is 1 plus sin t, its derivative is cos t. So, it is cos square t, which is 1 here. Therefore, the integral will be the surface area will be the integral 0 to 2 pi as t varies. 2 pi times it is about x axis. So, you take 2 pi times y at t square root of x prime square plus y prime square dt. So, that is 0 to 2 pi, 2 pi into 1 plus sin t dt, right. This is becomes 1, this under root becomes 1. So, y of t is 1 plus sin t. So, you get 2 pi 1 plus sin t dt. Now, you integrate this. So, it is 2 pi, 1 gives you t and integral of sin t is minus cos t. So, you get 2 pi t minus cos t evaluated at 0 and 2 pi, and that simplifies to 4 pi square. So, this is how we are going to find the area of the surface of revolution. Now, basing on these 3 types of possibilities, we go for these for some problems. Let us see how we are able to use these things. So, let us take the first exercise. Here we have the we want to find the lateral surface area of the cone, right, generated by revolving the line segment y equal to x by 2, x varies between 0 and 4 about the x axis. So, here what happens, it is about the y axis. So, we need a function y equal to some function of x, it is already given y equal to x by 2. So, we differentiate it, we get y prime equal to half. So, that the surface area will be integral 0 to 4 2 pi y square root of 1 plus y prime square, right. So, 2 pi y is x by 2 and it is square root of 1 plus half. So, 1 by 4 square root. So, that gives 2, 2 gets cancelled, we have pi, and this is a number which is say root 5 by 2. So, pi root 5 by 2 into x by 2, x by is into x, right, 2 gets cancelled here. So, pi root 5 by 2 into x, x has the integral as x square by 2 to be evaluated at 0 and 4, and that simplifies to 4 pi times root 5. Fine. So, let us go for the next problem. Of course, here is some way to see that it is really conforming with our geometric formula. It is half base into circumference into slant height, right. It is a cone, that is how. Okay, that is a verification. Now, find the area of the surface generated by revolving the curve y equal to square root of 2x minus x square, and the curve, the portion of the curve which is obtained by varying x between half to 3 by 2, and this surface is generated by revolving this portion or arc of the curve about the x axis. So, it is about x axis. Again we should find the formulas y is a function of x, which is already given. So, one thing we should verify that it should remain above the x axis, and that is there. It is square root of 2x minus x square is greater than or equal to 0. So, now we differentiate. So, y prime equal to it is square root of 2x minus x square. So, it is 1 divided by 2 square root of 2x minus x square. Then derivative of 2x minus x square with respect to x, that gives you 2 minus 2x. So, 1 2 gets cancelled, we get 1 minus x divided by square root of 2x minus x square. So, 1 plus y prime square is 1 plus 1 minus x square divided by 2x minus x square, which simplifies to 1 divided by 2x minus x square. Then we get the area of the surface, as this is the area, that is integral for the x limits half to 3 by 2, 2 pi y, which is 2x minus x square, square root, and then square root of 1 plus y prime square. So, 1 plus y prime square, if you take 1 plus this square and its square root. So, that gives square root of 1 by 2x minus x square, right. So, that is 1 plus y prime square we have computed, 1 by 2x minus x square. So, it is just square root of 1 divided by 2x minus x square. So, multiplying this we get directly square root of 2x minus x square, this gets cancelled and you integrate that. So, 2 pi minus x square into 1 divided by 2x minus x square into 1 divided by 2x minus x square, that gives you 1. So, it is just 2 pi dx, that is what we wrote. So, that gives integral as 2 pi x evaluated at half and 3 by 2, and that simplifies to 2 times pi. So, you should verify these things. If there is some mistake, then you correct it. Okay, let us take another problem. Find the area of the surface generated by revolving the curve. It is always the portion of the curve, right, revolving the curve x equal to y to the power 3 by 2 by 3 minus square root of y, where y varies from 1 to 3 and about the y axis. So, it is already given. When it is revolution is about the y axis, we need to express x as a function of y, and it is already given that x is a function of y. So, it is straightforward, we have to compute the derivatives and so on. So, let us compute here, and we just verify one thing, that the curve should lie above the x axis. So, that means it should be greater than or equal to 0. But here what happens, y to the power 3 by 2 by 3, when y varies from 1 to 3 is less than or equal to root y, right. At 1, of course, you can see it is 1 by 3 minus 1, at 3 also similarly, throughout it is y to the power 3 by 2 by 3 minus root y is less than or equal to 0. So, that means we should consider its negative, fine, to get the correct area. Area will be anyway modulus of that thing, integral. So, we are assuming greater than or equal to 0. So, we consider its negative, that is x equal to minus g of y. So, here we take directly x equal to g of y is minus of that, which is root y minus y to the power 3 by 2 divided by 3. Now, had you not taken it, we would have got a negative answer, right, but it should be same in absolute value. So, we consider this square root of y minus y to the power 3 by 2 by 3. Now, if you differentiate, that gives you half times y to the power minus half, and this to the power 3 by 2 by 3 gives you y to the power half. So, 1 plus x prime square is y to the power half plus y to the power minus half square divided by 4. It becomes plus now, because 1 plus is there, and we need the square root. So, we have expressed as a square of something. Okay. So, the surface area will be integral 1 to 3 in y, limits are in y, 2 pi. So, g of y, which is y to the power half root y minus y to the power 3 by 2 by 3, and then square root of 1 plus x prime square, which is y to the power half plus y to the power minus half by 2 dy. So, now to integrate it, you just multiply. So, that gives 1 plus 2 by 3 y minus 1 by 3 y square, and its integral we have to compute. So, 1 gives y, 2 by 3 y gives y square by 3, 1 by 3 y square gives y 3 by y to the power 3 by 9. So, evaluate at 1 and 3 and simplify, verify this, that will be equal to 16 pi by 9. Okay. So, maybe let us take one more problem. Find the area of the surface generated by revolving the curve x equal to y fourth by 4 plus 1 by 8 y square when y varies between 1 and 2 about the x axis. Had it been about y axis, then directly you would have done it, but now you want this curve is generated, this surface is generated by revolving this curve about the x axis. So, you need to find y in terms of x, right, but it looks complicated that way, and limit of y also given, you may have to find for x. So, instead of going directly through that, let us compute ds, right. So, ds is anyway 1 plus dx by dy square times dy, we can compute ds that way. So, then that gives you dx by dy equal to y cubed, y fourth by 4, derivative is y cubed, 1 by 8 y square gives 1 by 4 y cubed. So, ds we can see square root of 1 plus y cubed minus 1 by 4 y cubed square times dy, which is y cubed plus 1 by 4 y cubed dy, fine. Then we can directly get the surface area, but since it is about x axis, we would take 2 pi y ds as a function of y. So, all that we have to do is, we are using that unified formula, which becomes easier to apply. So, we say it is 2 pi y times ds, and s is a function of y now, looking at that way, because limits will be for 1 to 2 for y. So, that is the integral 1 to 2 pi y, and our ds is y cubed plus 1 by 4 y cubed dy. So, that directly gives 2 pi y cubed plus 1 by 4 y cubed dy. Now, we integrate this. So, first one is y fourth, that gives y fifth by 5. Next one is 1 divided by 4 y square, that gives minus 1 by 4 y, right. So, it is 2 pi times this, evaluated at 1 to 2. So, verify that simplifies to 253 divided by 20 times pi. So, here is a trick which where if you use the unified formula, it will be easier. If you go directly, it will be a bit complicated. Okay. So, now we go to exercise 5, where we want to find the area of the surface generated by revolving the curve. It is given in parametric form now, x equal to t plus root 2, y equal to t square by 2 plus t root 2, where t varies from minus root 2 to root 2, and this curve is revolved about the y axis, fine. So, this is given in parametric form. So, you must get their derivatives. So, first is dx by dt, which is 1, and dy by dt is t square by 2 gives t root 2 gives root 2. So, t plus root 2. Then we compute ds, which is square root of dx by dt square plus dy by dt square. So, that gives t square plus expand t plus root 2 square. So, that gives 2 root 2 plus 3. This t square is here, and then 2 root 2 is here, and then we have 1 here, and another 2 comes from here, that comes to 3. So, it is square root of t square plus 2 root 2 t plus 3 times dt. Then the area we can write now, it is about y axis. So, it is 2 pi y ds, fine. So, remember, when you take the other formula in terms of x, it will be 2 pi y dy, right. X is a function of y, you have to express. So, here directly we get 2 pi y ds. Is that all right? Because okay, you can see that what happens. in the earlier problem, we have taken ds equal to dy. So, it is 2 pi y ds. So, the same thing we are applying here, but now it is given in terms of parameters. Formula is the same. So, it is really s of t, where t varies from minus root 2 to root 2. So, we get minus root 2 to root 2, 2 pi y ds. This y should be expressed in terms of t now. Everything should be expressed in terms of t. So, 2 pi, your y is t square by 2 plus t root 2 times ds, which is square root of t square plus 2 root 2 t plus 3 and dt. So, how do we integrate it? So, problem is t square plus 2 root 2 t plus 3. So, let us take that to be u. So, let us substitute u equal to t square plus 2 root 2 t plus 3. Then we get du, take its differential, that is derivative times dt. So, that becomes 2 t plus 2 root 2. So, 2 into t plus root 2, 3 gives 0. So, that is this times dt is your du. So, when t, we must get the limits, when t equal to minus root 2, substitute minus root 2 here in the expression for u, you get 2 minus 4 root 2 plus 3, right, t equal to root 2. So, root 2 into root 2, that gives 2. So, 4. So, that gives 2 plus 4 minus 4 into 3 plus 3. So, that gives you 1. So, t equal to minus root 2, u becomes 1. When t equal to root 2, you get all of them are plus. So, it is 2 plus 4 plus 3, that gives you 9. So, the limits for u are known to be 1 and 9 now. Then you can write the area directly in terms of u. So, it is minus root 2 to root 2 becomes 1 to 9 pi, and this times dt becomes your du and the square root of u. So, pi root u du, that gives you pi 2 by 3 u to the power 3 by 2 evaluated at 1 and 9, and then that simplifies to 52 by 3 times pi. Just verify it, what happens to 9 and 1, and then simplify. Okay. So, let us take one more last problem. So, find the area of the surface generated by revolving the portion of the asteroid. So, you have seen asteroid earlier, 4 petals were there. Now, we have only 2 petals here, because x varies from minus 1 to 1. X to the power 2 by 3 plus y to the power 2 by 3 equal to 1 is the curve, and the portion of the curve is described by limiting x to minus 1 to 1, and this is revolved about x axis, So, we should get the formula directly. Say y equal to, if substitute from this, y is greater than or equal to 0 now. So, y equal to 1 minus x to the power 2 by 3 to the power 3 by 2. Y prime is minus x to the power minus 1 by 3 into 1 minus x to the power 2 by 3 to the power half. So, you get y prime square as x to the power minus 2 by 3 minus 1. So, the area is integral minus 1 to 1 for the x limits, 2 pi y, because it is about x axis, times square root 1 plus y prime square dx. So, you just substitute all those things we have got earlier. Y prime is square is plus 1 is x to the power minus 2 by 3. So, that gives square root x to the power minus 1 by 3, and y is this one, 1 minus x to the power 2 by 3 to the power 3 by 2. So, you get 2 pi into this, and it is to be integrated now. So, to integrate it again, we take 1 minus x to the power 2 by 3 as u, and then du is minus 2 by 3 x to the power minus 1 by 3. So, 1 3 has to be divided and multiplied. So, that gives you the integral as 1 to 0, because u varies from 1 to 0 now, 1 to 0, 4 pi u to the power 3 by 2 minus 3 by 2 du. Okay. So, 3 is coming here now. So, that simplifies to 12 pi by 5, just verify them. So, we stop and we declare that with this course is over. So, I hope you have enjoyed this course.